Let's talk about the probability of independent events. In this first example, a die is rolled twice. This would be a regular six-sided die. What is the probability of showing a 1 on the first roll and an even number on the second roll? Now, what happens on the first roll has no bearing on what happens on the second roll. This makes these two events independent. So, we have an ability to solve this problem already by looking at the sample space. So the way the sample space is set up is two numbers representing what you get on the first roll and what you get on the second roll. So there are 6 different rolls that can happen if you get a 1 first and then a 1, 2, 3, 4, 5, or 6 second. So there's 6 there, 6 there, 6, 6, 6, and 6. So there are 36 total things in the sample space. So the probability of a 1 and an even, we know will be out of 36. Okay, now, how many successes are there? A 1 on the first roll and an even number. So we're looking at this one, and this one. There are 3 that are a 1 and then an even. 3 out of 36, which reduces to 1/12. So these events are independent. When you have independent events, there is another way to do the problem. And that is probability of 1 times the probability of even. This only works for independent events. The probability of getting a 1 for a 6-sided die is 1 out of 6. The probability of getting an even for a 6-sided die is 3 out of 6. This gives us our 3 out of 36, which reduces to 1/12. So you can work this probability out directly by looking at the sample space, or you can use the independent events, the AND rule for independent events, to work out the simple probabilities and multiply your answers together. Now, in a moment, you'll pause the video and work on the right side. I want to point out that the rule is really an important rule to do because the sample space might be a little much. So the general counting principle is something you might know, but there are 6 possibilities on the first event, and there are 6 possibilities on the second event, giving us a total of 36 things in the sample space. Not too bad to list. For the second one, a jar contains 12 red marbles and 6 blue marbles, so there's 12 in one and 6 of the other. Now we have 72. And I don't really know if you want to list the sample space that has 72 elements in it. So I recommend that you work on the independent multiplication rule to work on the problem on the right. So go ahead and pause the video and work that out. All right. So since the marble is replaced in the jar after the first event of picking a marble, this makes it the second event independent, and we can do a simple, the probability of blue and even equals the probability of blue times the probability of even. This gives you 6 out of 18 times 9 out of 18, which reduces to 1/6. All right, I hope this helps.